Dia uno by Mr. Kabongo from the Congo. All right, what are we going to work on today? Today, you're diving into a new function. It's called logarithm. All right, logarithm. So we're going to talk about transformation of logarithm. So what are we going to do here? Let me zoom in. First, we always start with the parent function, right? With the parent function of a logarithm, it goes as follow. So here's a parent function. We're going to write it such as log of x. Now, your next question is, what does it look like? What is a log? If you graph the parent function, what does that look like? Well, the parent function will always start at 1, 0. 1, 0 is right here. Okay. Always. The parent's function will always start at 1, 0. Not only that, it also always will have a vertical asymptote. The vertical asymptote is located at x equals 0, meaning the wall. So you probably is like, well, you're writing too much, Mr. Kabongo. Well, here's the wall. X equals 0 is right here. That's the vertical asymptote for the parent function, and we always be located here. It means when I graph it, it will not cross this green line. So let's graph this. So when you're graphing the parent function of this logarithm, one side goes that direction, and the other side goes the opposite direction, but it will never cross the green line, but it will get closer and closer, but will never cross the green line. All right, so let's do this thing. So let's start with the domain. The domain will be the far left that it will not cross. It will have to be from 0. It will never cross 0. We get closer to 0. That's why I'm using parentheses from 0 to infinity. The range will be started at the bottom of the bottom, negative infinity, to all the way up to positive infinity. The range will always be the case. This will always be the case for the range. The vertical asymptote, which I also call it the wall, in this case for parent function, we just said that it was x equals 0 for the green. Let me use green so we can see that. All right. So let's talk about what the a, b, and everything does here. So the a value, let's use a different color. Let's go back to black. A value, which is the a right here. The a value, if a is greater than 1, then we have a vertical stretch. If a is less than 1, then we have a vertical compression. All right, just remember those. All right, C, when it's positive, we're going to go to which direction? To the left, to the left, to the left, to the left. And if it's negative, to the right, to the right, to the right. Same thing with the value of D. If it's positive, we're going all the way up. If it's negative, all the way down. All right. Cool. Let's put that into work. Oh, right here. Let's do number 1. Remember what I said earlier, that the parent function will always start at 1, 0. Right? That's for the parent function. So we're going to plot that right here. This will kind of just help us graph this. So by observing this, I know it has a minus. So that means this thing went to the right 1 unit. Then it has a +2. So that means down 2. All right. So from this parent function, we need to go right 1 and up 2. So we are right here. All right, so let me get rid of the old one. Boom. All right, so also my wall, where would that be located? My asymptote would be located at the opposite of this. So this is x minus 1, so it's located at x positive 1. Positive 1. So my wall is exactly at 1. So let's go ahead and draw that wall at 1. Boom, 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 boom. There you go. All right, now you can just draw your graph. It goes that direction over her. Let's use red. Goes that direction over here. Little nice little turn that direction. It's not perfect, you know. It's really not perfect. And also, you have your Desmos to always double check this stuff too. All right, so we said that the domain here goes from 1 to infinity because it's getting closer to 1, but it would never touch 1 because that's where my asymptote is. The range started at the bottom to infinity. Remember, the range will always be this case for the logarithm. And then we concluded that the vertical asymptote was just the opposite of what was inside, so it's positive 1. Not difficult, was it? Pretty simple, right? All right, let's do another one right here, number 2. Numero dos. With numero dos. All right, so let's talk about where do we always start? We always start at 1, 0, and then we go from that. That would be my parent function. According to this graph, it looks like I'll be, because of this plus right here, I'll be going to the left 1 unit. Because of this minus, I'll be going down 3. But most important, because of this minus at the front, I'm doing the reflection over the x-axis. All right, in that order. So reflection of the x-axis, move it left, move it da. All right, so let me go ahead and plot our 1, 0 right here. So we need to do a reflection over the x-axis. Where's the x-axis? This is the x-axis. Reflect over that. You are not here. Boom. All right, let's erase. And then he's going to move left 1, and down 3. Left 1, down 1, 2, 3. He's right here. And then remove the old one. Boom. All right. So now what? Now let's graph this thing. But before you graph it, remember you always got to find your vertical asymptote, which is x equal the opposite of what's inside here. The opposite of what's inside right here, that is a positive 1. So we're going to have an asymptote as negative 1. All right, where's negative 1? Right here. Let's draw a wall. Boom, 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 bada, boom, bada, boom, boom. There you go. Now we can draw our graph. It goes this way, but it would never hit my green graph, and then it goes the other way. Hey, voila. Cool. Now, pretty much done. Domain. Domain is going to go from, it's coming from negative infinity. From far left is negative infinity, but it would never cross the negative 1. Boom. Range. Always started at the bottom. Now we here. Always the case. And then we concluded that the vertical asymptote was a negative 1 from the opposite. See? That's not difficult, is it? All right, ladies and gentlemen, the next